In this video, we're going to address some angle word problems. And there are a lot of possible things we can do in here that we'll review all of them. But basically, we're going to try to find missing angles for various reasons. So our first example, and we'll get back to this after we talk about some of the things we learned, but it says you are driving north toward an intersection in order to turn right. When you finish your turn, you realize you only turned 83 degrees. This bothers you because you think or believe that all streets should meet at right angles. Spoilers, they don't all meet at right angles. This gets you wondering, if you turned left instead of right, how many degrees would you need to turn? Now, some of you may know the answer already, but let's go through and address what we have going on here. So the first thing we had were sort of angles in a polygon, and there were two rules that we were dealing with here. So we first had the rule for triangles, and in any triangle, if I have three angle measures, I know that they have to add up to 180 degrees. And so I can use that to find any missing angle if I'm given two of them. We also had, for the sort of general case, for polygons. And if we have n sides, this tells us that the sum of angles, interior angles, will be n minus 2 times 180 degrees. A little example so we can really tie in what this means, and we did this stuff last week if you want to go back to those previous lessons. But if I had a diagram like this, so something that looks like a nice little pentagon that has 5 sides, 5 angles, clearly not all the angles are the same. I know that I can add them all up to 5 minus 2 times 180 degrees. If I go through the calculator, that's 3 times 180, which is 540 degrees. And I can say, okay, they all add up to 540 degrees. So A plus B plus C plus D plus E. So this is sort of a general type of problem that I can apply to many different shapes. It still works for triangles, but we will just sort of resort to this known fact as opposed to this more general formula if we have triangles. Okay, simple angle pairs. So we had a couple of them. So one of them, the first one we saw, was for vertical angles. That's where we have two crossing lines. And vertical angles, I'll put an x and a y, will be congruent. So I'll just have x equals y. Usually it's very simple to solve. We also had a linear pair. And a linear pair is just a special case of supplementary angles. And so a linear pair, we will have two angles that actually come together to form this straight line. And whenever I have a linear pair, I'll have x plus y is equal to 180 degrees. I say it's a special case of supplementary angles because supplementary angles don't need to be connected. I don't need to see the straight line. They could be separated like this. Where if I put them together, okay, I'd have this diagram, but I don't actually see the line being formed. The final simple angle pair we had was for complementary angles. And that's just two angles that come together to make a right angle. And complementary angles add up to 90 degrees. Okay, now the last thing we saw was parallel lines and transversals. And there were many different names, again, go to the previous videos if you want to see more specifics on this style, but the basic rundown we had was this. If I have two lines and they are parallel, and I have a line that crosses them, that's called the transversal, there are actually only two things that can happen. Either I will have angles that are equal or congruent, so each of these x's is the same, each of these y's is the same, or I would have one of each, in which case I'd have x plus y is equal to 180 degrees. Okay, let's dive into a couple examples. So here's our first one. Again, you're driving north towards an intersection in order to turn right. Okay, so let me draw the diagram. Now, I'm going to have it sort of horizontal and vertical, but there's nothing saying that I can't tilt these lines a little up or a little down. Most cases, most streets are not perfectly north-south, perfectly east-west. There could be a little bit of leeway to that. Okay, but you are driving north, so you are down here and coming up north. When you turn right, so you're turning right, you know that you made an 83-degree angle. You want to know how far you would have to turn if you're turning left. Well, these are two angles that make a straight line. That means they're a linear pair. That means x plus 83 has to add up to 180. And I'll just subtract 83 from both sides and get that my left turn would have to be 97 degrees in order to get onto the street. Another example. So you are obsessed with drawing the perfect x. In order to draw the perfect x, you need to make the top angle measure 45 degrees. If the top angle measures 45 degrees, what's the measure of the bottom angle? Well, let's try to draw the perfect x. You know how all of my x's, all my letters are perfect. So, yeah, perfect. There we go. And we're saying, okay, the top angle measures 45 degrees. Now, as a math teacher, I don't like how I phrased this question, because what I mean by top angle, but as a human, as an English speaker, I'm like, okay, 45 degrees, I mean it should go right here. Fair enough. That's, I guess, pretty self-explanatory. All right, I want to find the measure of the bottom angle. Well, if this was the top angle, the bottom angle should be down here. And I notice these, I have intersecting lines. I have angles that are across from each other. These are vertical angles. So I just get y equals 45 degrees. One final example. So you are sitting in art class, but as always, still thinking about your favorite class, math. In art class, your teacher tells you to cut out a parallelogram. You cut the first corner of your parallelogram and immediately break out your protraction measure, because why wouldn't you? I mean, you want to see what the angle is. It measures 61 degrees. It's not what you wanted. You really wanted that 60 degrees and you missed. Well, you know, you can't always get what you want. You got to go on with life sometimes. When life gives you 61 degrees, you still make a parallelogram. What you're wondering is, what should the angle of your next corner be? So let's draw this. Now there's a couple of possibilities. So I have this parallelogram. That means that these sides are parallel, these sides are parallel. You might be tempted to use this n minus 2 times 180 degrees, which is going to be 4 minus 2 times 180, which is equal to 360 degrees. But this is really not necessary for the problem at hand. So I'm going to sort of cross this off. I'm not going to use that and add up a bunch of angles. What I am going to do is this. So we cut our first corner and it was 61 degrees. Okay, so I'm cutting, and then I'm coming around. I have to figure out how large this next corner is going to be, what this angle is going to be. So I put an X there. What we have is we actually have parallel lines and a transversal. And I notice that these angles don't look the same. I notice that this one's acute, this one's obtuse. I notice that these are same side interior angles, and that means x plus 61 equals 180. I'll subtract 61 from both sides, and I'll get that x is equal to 119 degrees. Okay, so I'm going to cut this off here. If you have more questions, need more help, there will be a link to a video in the description where I go through some more example problems. There will also be a link to a worksheet so you can get some practice. There is one style problem that I did not cover here that I cover. I think it's the second problem I cover in the examples that I would highly recommend that you look at. It shows up 2 or 3 times on the practice worksheet, so I would recommend going through that. All right.